people from architecture, like a mechanical sort of thing and stuff like that. So it's like, yeah, different, really good bunch of group.
Fantastic.
Yeah,
Any WM here from South Africa?
I guess not.
Guess not. Too bad. I had some job openings in Cape Town.
Yeah, probably next time we should have someone from South Africa. Yeah.
You
Okay.
tell me when we've hit critical mass.
Yeah. Um, yeah, I'm still expecting 4 or 5 more students because they confirmed that they'll attend. But in the interest of time, I know it's a Friday, so Brian, if you want to start at this point, I mean, I'm okay with it.
We can wait a couple more minutes. That's
Okay.
totally
Yeah. Sure.
fine.
Yeah. Sure.
I have
Let's.
meetings after this, so you're not keeping me from anything.
Oh, okay. Cool. Okay. Great. That's awesome. So let's wait 2 more minutes because I think a few more students will join.
Plus.
Yeah. I think looks like this is it at this point, Brent. So yeah. Yeah, if you're okay, I mean, we can start this and I can give a quick round of introduction at this point if you want.
Sure. Yeah.
Yeah. So yeah, really thanks for your time and effort in presenting to us, Brian. So again, this is a course for CIV ENGI 9710, Sustainable Civil Infrastructure Systems. So this is kind of the first course in the program. Like I'm teaching this at this point as like a brand new course. What the students are exposed to at this point is basically like very high level stuff on like what's the sustainability and resilience concepts are, what it means for the engineers, how they can apply some of those um, in some of their like infrastructure projects. So basically what we're kind of covering here is not like any specific infrastructure, rather like a wide range of infrastructure. So not only technical aspects, but also non-technical aspects, like what's the ethical issues, what's the environmental issues, and all those like different aspects. So the students are doing two interesting things as part of the project. Number one would be they're looking at an infrastructure failure that has already happened, and all the like investigation reports are there. So they're looking at that failure from different perspective and kind of mapping the reasons of the failure. So whether it's a technical, whether it's a non-technical, and different aspects of a problem. So that's one of the things that they're doing. And the other thing they're doing is a term project is looking into the resiliency tools that are available in the current practice, especially for the linear infrastructure systems, like whether it's a roads, railway, dikes, like any sort of pipelines, any sort of linear infrastructure. And they're kind of doing sorry guys, I'm hearing a news. I'll just, it's okay. Okay, yeah. So they're part of looking into those like available tools and find out the pros and cons on each tool, and really like at the end of the day using their engineering judgment to figure out like what's needed for future. So that's kind of two interesting projects they're doing as part of the project. And this is where they are sitting at this point. So yeah, definitely we are very excited to have you, and I think the topic is very interesting. So we just keeping it that mind, like feel free to share some of your insights, and we'll go from there.
Happy to. And I'd like to thank everyone for the invite and for the time today listening to me babble on about something I'm pretty passionate about. So my name's Brian Dickerson. I am the infrastructure sector leader at Woolpert. I'll give a little bit of the background at Woolpert to help you understand who we are, and I'll also share a little bit about my personal background because ironically enough, I am not an engineer, but I run a group of engineers. So topics today, I want to talk a little bit about how the profession of civil engineering has evolved, particularly in the area of digital twins and BIM and AI and how that's had an influence and an impact on the industry. Also talk to you about some different examples of how true digital twins, because digital twin is such a buzzword in the industry today, how true digital twins can be used to manage various types of infrastructure. And most importantly, what the value of those systems are to those responsible for managing that infrastructure. Another big topic today is AI and how do we apply that to civil engineering practices and apply it in both an efficient but also ethical way. And then end with some discussions around how you prepare for your profession with how the industry is changing and changing so fast in these days. So I will offer, please let's keep it very informal. If you have questions, let's talk about them right away. You're not going to bother me by interrupting me in the middle of the slide. So a little bit about Woolpert. So Woolpert was founded in 1911, and one of our original clients were the Wright brothers, the gentlemen who invented flight. The Wright brothers were from Dayton, Ohio. Well, after they made their flight in North Carolina, they eventually moved back to Dayton, Ohio, and got into the land development business. And one of the services, one of the companies offered there was land surveying. That's how Woolpert got started. And so they used Woolpert to help land survey a lot of the developments that they were developing in and around Dayton, Ohio at the time. So Woolpert has grown since then. We're now approximately 3,000 people with offices across the globe. So we're a top 50, number 39 actually, engineering news record ranked design firm in the U.S. And one of the top 500 EMR firms globally. So you can see on the map, we have offices across the globe. Nothing in South America, but offices everywhere else on the various continents. Primarily based in the U.S., Europe, Australia, and two fairly significant office presences in South Africa, in Johannesburg and Cape Town. So our vision at Woolpert is to be the premier global architecture, engineering, and geospatial company, and one of the world's best companies, particularly one of the world's best companies to work for. And what's interesting about that is that Woolpert sits in the AEC industry, architecture, engineering, construction. However, what's unique about us is the geospatial component. And that's very fundamental and part of our DNA as a firm, and very applicable when we talk about digital twins and artificial intelligence, that that drive towards technology and that drive towards innovation into what we do. So Wolpert is divided into, I'll call it three sectors. One focused on architecture, one focused on engineering, and one focused on geospatial. So the one focused on architecture we call our buildings sector. And they do kind of what it sounds like they do. They architect buildings, they design buildings, the structures, data centers throughout the world. So they work with federal, private, and public clients worldwide. We are one of the top 4 data center designers on the globe. Our clients are Meta, Google, Microsoft, Amazon, all the big players that you would expect. So the portion of Wolpert that I'm responsible for and I run is our infrastructure sector. And this is where the bulk of our engineers reside. And our clients are aviation clients, electric utility, energy clients, surface transportation clients, and water clients. So think about the critical infrastructure that allows people, goods, and services critical to economic or health and human safety, how they move and get delivered across the globe. That's who we service. So airports, investor-owned utilities, public-owned utilities, municipal utilities, state departments of transportation, designing roads, bridges, airports, electrical substations, dealing with flood mitigation, wastewater collection, water distribution. That all falls within the infrastructure sector and falls under my purview. And then lastly is our geospatial. So when we say geospatial, geospatial technology, such as geographic information systems, I'm sure you all have encountered those at one point or time in your careers or in your studies. Geospatial technologies are inherent in everything we do across all 3 sectors. So my background is GIS, actually. We utilize GIS in every part of the organization. When we talk about geospatial, what we're really talking about is large-scale data collection. So we're talking about statewide photogrammetry, statewide LiDAR, even countrywide LiDAR and photogrammetry, particularly in the African subcontinent. We do a lot of that. Bathymetric LiDAR. So when you think about dealing with coastal erosion and climate change and human impact on the environment, we have vessels that take bathymetric LiDAR measurements of coastlines to identify where we have areas of coastal erosion. We're doing that all around the entire state of Florida right now, dealing with the after effects of hurricanes. So when we say geospatial, that's what we're talking about: large-scale, high-precision data collection. But that data is then used in any number of architecture or engineering applications. So I'll come back to my background. My personal background, I have degrees in geography, geology, and chemistry. And I actually began with Wolpert in the late 90s as a software developer for geographic information systems. And my career kind of took a turn where I got into asset management, so infrastructure asset management. So that got me into projects and clients and programs around how to help infrastructure clients, an airport, a municipality, a state, a department of transportation, a utility, how it got me into projects and programs to help them understand they have a massive fiduciary need to manage aging infrastructure, and they have a responsibility to provide water service or wastewater collection or electric utility service to a ratepayer, um, accessible and safe roads to public constituents. Well, they have massive fiduciary needs for aging infrastructure that exceeds their capacity to fund and effectively rehabilitate and replace all of that infrastructure at any one time. It's particularly a challenge with buried infrastructure because by human nature, anything out of sight is out of mind. So you think about, a typical U.S. domestic utility, water and wastewater utility, they may have billions of dollars of infrastructure underground at any one point in time, critical to how a community operates and sustains itself. But they may only have a small fraction of that to spend on an annual basis to improve it, to replace it, or even to repair it. So how do they make good decisions on where to apply those funds? That's where asset management comes in. What am I inspecting to get a better understanding of what its true condition is? What am I repairing? What am I replacing? How am I repairing and replacing that infrastructure? Asset management allows them to make informed decisions balancing infrastructure performance, cost, and the risk proposed to their stakeholders should that infrastructure fail. Well, my being involved with that got me involved with understanding all of these different types of infrastructure, working very closely with a lot of our engineers to, once the financing decisions were understood, how they would go about designing projects to address those needs. And over the course of my career, became much more familiar with the actual planning, design, and construction of this infrastructure, and landed me where I'm at today, where I'm responsible for this entire division of Wolpert. So it's been an interesting career. My own daughter, my oldest daughter, is studying to be a civil engineer herself, and she asked me what I do, and I was like, well, I don't design anything. I'm not an engineer. I help the engineers figure out how to make money at the end of the day. So that's kind of how I got to where I'm at. Because of that background, I've been involved a lot in our AI initiatives, our digital twin initiatives, which is why I have such a passion for this topic. And when you think about if you look at the average layperson and talk to them about, well, what's really changed in how we design and build roads and bridges? I mean, Leonardo da Vinci, designed bridges, and one of the most efficient and effective bridge designs ever. What's changed since then? Well, actually a lot. While the layperson would probably think not much, what's actually changed is quite a bit. Even in how we go about designing infrastructure. We've gone from hand-drawn blueprints to modern drafting tools and drafting tables to now the invention of CAD in the 1950s with Pronto and Sketchpad and the introduction of Autodesk in the 1980s. In the 90s, we started getting building information models as poorly named because it's used for more than just buildings. But now we have intelligent three-dimensional models of the things that we are designing. And we have more than just the points and lines and polygons and text. It's intelligent data. I can put on a pipe, and the pipe will tell me much more beyond like where it's at, but its diameter, its size, all of that information. In 2000, we saw the introduction of Revit, and now as we're progressing into the 2010s and 2020s and beyond, now we're truly getting into the concept of digital twins, which means we're no longer designing objects. We're designing entire ecosystems of things that they sense, they decide, they respond. And the perfect example, my background is mostly on the water wastewater side, so a lot of my examples will tend to lean that way. I think about water and wastewater treatment plants from the late 90s, when you would design the water and wastewater treatment plant to communicate how that treatment process worked. A lot of times we would create what were called process and instrumentation diagrams, PNIDs. That's now evolved into 3D models and the true integrated process twins, where we have sensors that give us real-time information and feedback on how that process not only works, but how it's performing at this moment. Another example is a bridge today with the appropriate sensors built into it can tell you how it's under stress at any one time. A pump can tell you when it's about to fail at an oil refinery. And the important thing to think about here is that a lot of folks might think that this means that technology is replacing engineers, and it's not. It's really augmenting your judgment and allows you to make better, more informed decisions on how you manage this infrastructure. So when we talk about digital twins, when you hear the term digital twin, what do you all think of that term? I'm curious. I'd love to get some feedback from you all. When I say digital twin, what do you think of in your mind?
I can answer right one of the I can think it's like a computer simulation of a real structure, like a twin, which is more like an online version or like a computer visualization.
Yeah, I saw something pop up in the chat here. What was
We got one
the
answer
digital
that
version of an existing piece of infrastructure? Yeah. A lot of folks, a lot of engineers in the AEC industry, when you say digital twin, there even today is a misconception that a digital twin is a 3D model of the real thing. Um, and I would say that's partly true. It's not a visual. A true digital twin is a twin. It's not just a visual representation. When I think about if I had a twin like me, that twin would breathe, it would sense, it would learn, it would adapt. It's not just a mannequin representation of me. A digital twin, it is all of those things. It really, the emphasis of the digital twin is that it's providing you real-time operational intelligence from as designed to as performing in this moment. So a true digital twin is not just an accurate representation of how it was designed, and built. It's an accurate representation of that plus how it is performing in this moment. So again, not just a 3D model, it's a living digital replica of what we're looking at. And that means that we're combining a lot of different things. We're combining the geometry, the location, which is important because we're talking about systems of things, right? So things have to operate together. Even as simple as like within a building, the geometry being used to represent a room needs to know where that room is located in relationship to the other rooms and the other parts of the building to do something so simple as to say, hey, this part of the building right here is experiencing high heat right now. So you have to be spatially aware. You have to have data streams. right? You have to understand what's happening in the moment. So that's where we get into supervisory control and data acquisition, SCADA systems. We have to have secure networks. So we get into the Internet of Things. We have to have real-time telemetry. With that comes almost an inundation of data. Well, how do I turn that data into actionable information and not just be overwhelmed by it? That's where analytics and AI and machine learning and dashboards come in. So our goal is to create an actual simulation to ultimately predict problems before they happen so that we can either prevent them from happening or optimize things to minimize their impact. So when I talk about having systems of things, a digital twin in and of itself is a system. So I have, if I start from the bottom up, I have the actual physical asset that I'm trying to maintain. And that asset here is a pump and a motor. It could be anything. But then I have to have a way to capture data about that asset. And that's where things like geospatial technologies to do terrestrial LiDAR or unmanned aerial systems to capture data. On my introduction slide with the agenda, that was a 3D model of a bridge that was captured all with drones with LiDAR sensors attached to them. We had a project where we had to understand the bridge was not built in the way it was designed, and it was causing a possible safety issue. It was failing. And we had to scan it without having any disruptive measures performed on it. So you have to understand where the assets are. You have to be able to capture them in relation to the rest of their environment. You have a lot of information about the assets that you need to combine together. You have your SCADA system that's telling you how that asset is performing right now in the moment. You have your enterprise asset and maintenance management system that tells you how this thing has failed or how it's been maintained over time and how old it is and what condition it's in. You have your BIM model to better understand how it is supposed to function in relation to the other assets that it interacts with as part of the system. And then we talked about the analytics of that's a lot of data coming at me at any one point in time. How do I combine that into data streams and information that I can make decisions on to provide me insights that then may change what asset I have in that location, how I maintain it, how I operate it. It can be a hugely powerful system when put in place. And I'll give an example. One of the clients I worked for many years ago was City of Des Moines, Iowa Waterworks at their water treatment plant. And they had, this is at their wastewater plant. They had, like any wastewater treatment facility, there's a lot of redundancy in equipment. You can't, it's not like a manufacturing plant where they're trying to spend the minimum amount to produce widgets out the end at any one point in time. With community infrastructure like a wastewater plant, it's all about redundancy and reliability and consistency of service. So in their aeration basins, they had a series of high service blowers that were set up. And Des Moines is one of the U.S. Cities where the electric utility provider, it's not a consistent utility rate. Based on different times of day, the rate that is charged to the consumer is different. So if I'm trying to run my air conditioner at 3 o'clock in the afternoon in July, that's a premium period of time, and so that electric utility provider charges their highest rates during that time. if I was running my air conditioner at 2 o'clock in the morning, when it's the time of day, means that the temperature is cooler, there's less demand on the system, I have lower rates at that point in time. Well, that's really important for the city of Des Moines at the wastewater treatment plant. They had a cycling schedule for these high service blowers. So they would run one blower for a certain amount of time, and they would take that blower off the line for maintenance and run the next blower, and then they would take that one off the line for maintenance and then run the next blower, and then cycle back through on a regular basis. Well, it turned out that their reasoning for why they used what blower at what point in the day was simply because their operators preferred blower A over blower C. What the digital twin told us and taught us is that they were actually using the least power efficient blower at the highest rate paying time of day for electricity use. One blower was not more reliable or more powerful than the other. It was simply a matter of personal preference. And it just so happened that that personal preference resulted in the least effective combination of equipment and utility rates possible. So the digital twin taught us that. And we were able to change things around a little bit. And ultimately, it resulted in a $400,000 per year savings to the utility just by changing the order of how they were cycling that equipment. There's no way to know that and understand that without something like a digital twin ecosystem that combines all of this information and can feed it to you in a way that you can start to see patterns and start to see problems and possible solutions. So a very good practical example of the benefit of the digital twin. So digital twins, again, I hate that most of the time when we think about it in terms of the building, but really a digital twin can be any piece of infrastructure. You know, when I think about it from a surface transportation standpoint, I think about it from things of smart highways and bridges that are telling me when bridges are operating under stress, or rail crossings and rail safety, being able to model traffic density, pavement condition, vibration detection, and understand and make better decisions on how we design, how we plan and place different pieces of surface transportation infrastructure together to get people from point A to point B in a safe and effective manner. When I think about it from an aviation standpoint, one of the programs that we have at Woolpert is with the U.S. Federal Aviation Administration on smart runways. So in a lot of the runways that we're designing and constructing right now at various U.S. airports, we're embedding piezometers and other sensors in the concrete to help us understand when concrete might fail on a runway. Obviously, as different airports are being used for larger and heavier aircraft, you know, think about the Airbus A380. You know, that plane lands at Denver International Airport, but Denver was never designed and built for anything larger than a 747. So what type of impact is that having on the health and longevity of the runways and taxiways at that airport? We're able to measure that in real time and start to understand when we might be approaching deployment failure and address those issues in the pavement before they happen. Because if one happens while a plane is landing, that could be catastrophic for health and human safety. When I think about water and wastewater, right? It's how is the treatment train performing? How can I optimize when I'm running what pumps, what chemicals I'm using? Here in my part of the United States, um, a lot of our source water comes from surface water sources, so rivers. Well, when you think about here in the central U.S., and I had the Mississippi River that runs north to south, there's a lot of cities built along the rivers. So on the north end of the city, there's the water treatment plant, typically. Then on the south end of the city is the wastewater treatment plant. So water comes in, it goes to houses, it comes out as wastewater, and it goes back in the river. Well, the next city down pulls it back, right? And it's a cycle that just repeats itself all the way down the river. In between cities, you have a lot of agriculture. So I have farmers putting pesticides and herbicides and fertilizer on their fields, and that's washing into the river. So the chemistry of our source water is changing on a daily, if not hourly basis. Well, how as a water utility can I sense that chemistry as it's coming into the plant and adjust my chemical usage in an optimized fashion to make sure that I'm, addressing all of a sudden the huge influx of nitrogen because we had a rainstorm upstream that washed fertilizer into the river, and making sure that I'm providing consistent and safe drinking water for my community out the other end. So a digital twin that can detect that, react to it, and change our processing as our source water changes is very important. When I think about energy utilities, electric and gas, storms have a massive impact. So how can I manage outages and reroute power by opening and closing circuits to make sure that if I have a substation go down here, how do I have a whole community over here that is not without power, or minimize a power outage as short a time as possible? That's becoming more and more important as we're dealing with climate change. And how do I design resilient systems and detect what's happening within my system so that I can minimize impacts to my communities? And then an interesting one that we've been involved in a lot lately is in hyperscalers. So hyperscalers are data centers, chip fabrication facilities, battery manufacturers. When I think about like making batteries for my Tesla, right? These types of facilities have very different requirements. They have hyper accurate interior survey needs. So I need to know where this data cabinet, the server cabinet sits, or where this chip fabrication piece of equipment sits, down to the nanometer within the facility. And I also need to measure and understand, is it experiencing any type of heat outside its normal operating parameters, or vibration outside its normal operating parameters? The fact that we have a computer in our hand is fantastic, but the smaller and more powerful these things get, the tolerances of the equipment inside of them become smaller and smaller, so that these facilities have huge needs to understand what's happening inside them right now. When I think about a water-cooled data center, this is an interesting fact. Data centers put off a lot of heat. Thinking about all the servers that you have. A more efficient way to cool that infrastructure is water cooling versus air cooling. However, water cooling requires ultra-pure water. And that's actually a category of water. Ultra-pure water, it requires 3 times the amount of potable water to create ultra-pure water. And if I get anything like mineral deposits in the water, that can affect the efficiency of my cooling systems within inside of the data center, which if the data center goes down and you can't access Facebook or Twitter or Instagram, all hell breaks loose at that point, usually, right? Society breaks down because we can't get on social media. But it's having real-time impact of what's happening inside the data center is critical to a lot of these providers. So why these digital twins matter is that we're very much shifting from designing and building infrastructure to now designing, building, operating, and optimize the performance of that infrastructure to maximize its lifespan. So digital twins help us achieve that. If we can do that, they allow us to extend asset life by on average 10 to 15% through more informed and data-driven maintenance practices and decision-making. When we talk about a lot of our public agencies, our municipalities, our provinces and states who have limited amount of funding, if we can extend the life of our infrastructure assets by 10 to 15%, that lets us take that funding go so much farther. So it's critically important for us to be able to make better asset investment decisions. It's a key tool in the toolbox to be able to do that. But it doesn't come without costs. There's some barriers to digital twins. Bentley and Autodesk, they create some fantastic digital twin tools, but obviously they are corporate entities in business to make money, so they want their ecosystem of tools to only work with Bentley or Autodesk products. So interoperability is important. A lot of organizations don't start down this technology pathway thinking about tying them all together at a later point in time. So they may have bought a best-of-breed CAD solution. They may have Revit. They may have an Esri GIS. They may have Wonderware SCADA, right? So how do I pull all of those things together and make them talk to each other? So that's the technology side of things. Then there's a culture shift, the people side of things, where I don't need just civil engineers. I need civil engineers that also understand technology, that are curious about how they can implement and integrate technology into their designs and into how that infrastructure is going to be operated and maintained and used. And then I also need to change the thought process and our work processes, because I can have great design, I can have the best technology tools in place, but if my maintenance staff who are out performing maintenance on the infrastructure, say they're out working on a road or a bridge, and they're not collecting accurate condition information or noting defects or really tracking all of the things they had to do to maintain that piece of infrastructure, then I don't really have a full picture. So it's kind of the garbage in, garbage out type of thing. So my how I go about doing my job has to understand the broader perspective and the full picture at the end of the day. And that can be a challenge, right? So it really is to get the most out of the digital twin type of solution in managing civil infrastructure. It comes down to the old adage of people, process, and technology, and I have to make sure that all three of those are working together in concert. As AI becomes a bigger part of this, it's important that we also address it. I think one of the misconceptions that we have about AI in the workforce, and I have this to this day, well, AI is going to take my job. What do you need to pay me for when a computer can do it, right? And I think that's, it may replace exactly what I'm doing today, that means that I'm freed up to do something more and bigger, right? It's not replacing this, it's augmenting this. Um, as an example, we do a lot of closed circuit television inspections of pipe, stormwater pipe and wastewater pipe, right? To understand where there's defects. Historically, it would have to be a person sitting down looking at either the video or the live camera feed of a robot going through the pipe to flag all the defects, what type of defect it is, where is it, how severe is it, to really get a full picture of the condition of that pipe. Well, now we have the same number of people that do that work. But now their job is, instead of 20 people working on one project to do that, I had 20 people working on 30 projects because the one person trains the AI for that specific system, trains it, okay, so they do maybe 10% of the system, saying, okay, AI is kind of watching what they do and following along, okay, that's a defect. That's this type of defect. So I see this pattern in the video. If it's this big, this is the type of severity I apply to that defect, right? It's learning from the person training it. And then it goes through and does the entirety of the system, maybe in half the amount of time, right? And now that person just needs to go spot check to make sure that it's the way they would have done it. And so now instead of 20 people working on that one project, I still have those same 20 people. They're able to work on more of those projects. And our error rate goes down and our consistency of information goes up. But we haven't tossed anybody a job, as an example. It's interpreting and learning from the humans. It's augmenting them and making them a force multiplier at the end of the day. One of the interesting things we're looking at right now and working with the U.S. Department of Transportation is, how do I incorporate AI as a co-designer of infrastructure? How do I use it from a generative design standpoint? So instead of us spending time drawing or designing one bridge, we describe the requirements. We provide the parameters. We provide the prompts of what type of bridge, what type of performance requirements does it have, and then AI helps provide us different options that we can work from and augment from, start from. It still requires human engineers. And at the end of the day, we have a professional and ethical responsibility as engineers to make sure that what we're designing and ultimately what is constructed is safe and fit for purpose. We still have to verify the constructability, the safety, and the context of any piece of infrastructure that we're designing, whether AI has a part in it or not. But it can allow us to work faster and more efficiently, for sure. It does not replace us. A very interesting example for how AI and digital twins can be applied in a real world is Wolfert has a solution that we call FloodTrax. So many of the communities in the southeast part of the United States, think North and South Carolina, Georgia, that's a very wet portion of the country, a lot of rainfall. And flooding is a real issue. Flooding that provides damage to property, flooding at a level that it has an economic impact, and then flooding at a level where it's a threat to human life. So it's a real issue that has to be addressed on a regular basis. Because of that, a lot of these communities have permanently installed flow monitors and flood sensors in a lot of their streams and culverts. And what that has provided over time is, from a digital twin perspective, we have real-time information for how the network, both natural and engineered, is performing, right? But we also have a vast amount of historical data. And what we came up with was an ability to utilize artificial intelligence and machine learning to look at past rain events and what the impacts of those rain events were in the system at that time, and then get it such that it was so efficient we could feed it a current rain event, and it would tell us, hey, you're going to have flooding in this area at this level X number of hours from now. This is what we need to do, right? We need to evacuate, or we need to, using our adaptive controls that we have on a lot of our flood management system, the levees and the locks, we can close gates, open gates, redirect flow in certain areas, and prevent damage to transportation infrastructure, prevent damage to the economy, flooding a business district as an example, or prevent any loss of life, right? So it's been a very successful tool for those communities that have had these permanently monitored rain sensors and flow monitors and flood level sensors. And it's a great example of a combination of the digital twin, artificial intelligence, and machine learning, and how that can have a positive impact on how we manage infrastructure, prevent damage to infrastructure, and ultimately have a positive influence on our community. The ethics of this gets very challenging, right? If you've designed a bridge and a bridge fails, you just can't tell the judge that, well, the algorithm said it was fine, right? But you still have a professional and ethical responsibility here. We've got to be diligent to follow NSPE and ASCE codes, right? We've got to hold paramount the health, the safety, the welfare of the public. So I would say we need to embrace AI, but don't ever outsource your professional responsibility or your conscience at the end of the day. It is a tool in the toolbox. It is not meant to replace good, human, informed, educated decision making. So what does the future civil engineer look like? If I had to pontificate 10 years from now, I've talked with my daughter about this, who I mentioned is studying to be a civil engineer. I think it's an evolution in the role, right? You're no longer a designer. You're now an integrator, a strategist, in addition to being a designer. You have to know how things can be built, but then be thinking about always the context of how is this road or bridge or railway or water line going to be used in the context of the entire system that it's supporting. It means that you're going to have some different skills, right? You're going to have to understand technologies like GIS, Power BI and data analytics and business intelligence and data visualization. Interestingly enough, my daughter is taking a class in Python scripting, which I applaud, right? An engineering program that's requiring that is key, I think. But I think ultimately the important thing is curiosity, right? Be okay thinking from a systems perspective, not just a thing perspective. I think if you advance in your careers, being digitally fluent will matter just as much, if not more, than being technically competent in the thing that you're doing. Again, technology will expand opportunity. It will not replace you as an engineer at the end of the day. I mean, the other thing I would encourage you, and again, school will teach you how to learn. Your career will teach you how to apply what you've learned. Uh, I really think that always being curious, not to steal from Ted Lasso, for those of you who are Ted Lasso fans, um, I think that's important as you grow in your career. Um, and I would tell you, don't chase titles. Chase what chase what interests you. Right? Be the type of engineer who asks, how can this system work better or smarter? Right? That will really help you advance in your career at the end of the day. So just kind of wrapping it up before we open it up for questions. I think understanding that infrastructure is becoming much more intelligent, much more interactive, and interacting with other pieces of infrastructure. You're no longer designing the bridge. You're designing the bridge in concert with the roads that approach it, with the rails that go underneath it, with the waterway that's happening, flowing underneath it. Having to understand the living, breathing traffic patterns of different times of day and how all of that works together to create a safe and efficient environment for a community. That you really are becoming a system architect at the end of the day. The thing I would say is, think about it, we still pour concrete, but now we pour data with it too. And how do you make decisions that account for all of that? So with that, I wanted to leave a bit of time for discussion and questions. So I'll pose a question that I'd love to hear. Kind of what surprised you most about this discussion on digital twins and AI and machine learning?
Hi.
Hi.
Uh, so I have a question. I just want to clarify that how does the digital twin update its internal model when a structure behaves unexpectedly, like a ground movement, something like that?
I'm sorry, can you repeat the question?
Yeah. So how does the digital twin actually update its internal model when a existing structure behaves like unexpectedly, like if there is a ground movement or something like settlement? Uh,
So with couple different ways. With I'll take the data center as one example. That one doesn't update the model, but it does set off alarms so that they can go investigate. Hey, we're having vibration in this area. What's going on? Well, someone's running a forklift next door, right? Um, when we talk about a bridge, as an example, we're working on right now the Brent Spence Bridge in Cincinnati, Ohio. It is the most important bridge for the north-south transport of goods in the U.S. It is between Cincinnati, Ohio, and Covington, Kentucky, and it goes over the Ohio River. That is a critical piece of infrastructure in the U.S. So we have sensors built into that as we're designing the new bridge, such that if there is settlement, if there is movement, it not only alerts ODOT, the Ohio Department of Transportation, but the digital twin that we're setting up as part of it, it will literally make adjustments in the BIM model based on the feedback it's getting from those sensors through some AI and some Python scripts and things like that take those data feeds and make those updates in the real-time BIM model so that you can see the impact and start model hey, if it sevels here a little bit, that's fine. A little bit more, that's fine. If it sevels this much, now we're putting some severe stresses on the system.
Oh, okay. Thank you.
Yes, okay, Chico.
Okay, so my question is quite simple. So if I want to create like a digital twin, I don't know, can you hear me?
Yeah.
Yeah.
Can you hear me?
Yes.
Okay, so if I want to create a digital twin, do you have a template on how to create, monitor, upgrade, manage, and use a digital twin to create for any infrastructure? Do you have a template that we can say, okay, this is the template. If we look at it, we'll be able to create a digital twin for our own selves. Thank you.
I would not say that there is a template yet in the industry, which is good. That means that's why people like myself are employed. But I do think as this concept and technology evolves over time, you will start getting to the situation where you have more packaged solutions, I would call that. But at the moment, I could not tell you that there is one all-encompassing template that you could apply. It's very much in the age of, and I'm probably going to date myself, a time where you could build your own computer, right? I could go get the motherboard here and the case there and the video card there and put it all together and I'd have my own computer, right? When I think about a digital twin, it's very much I can get the bin model here, I can get the sensors here. I mean, to build a secure network that is hack-proof, to put it all together at the end of the day, and it's not something I can go buy off the shelf at this moment.
Yeah. Thank you, Brian. I think like I just have a comment like with the question that you asked. I think what surprises me at this point is like the extent of the whole model, right? Like we are integrating like GIS, we're integrating artificial intelligence, like the power that we'll need to like make those simulations. I mean, like it's sometimes hard to believe that this is actually possible, right? At this point.
The Floodtraps model, if I had to guess, 10 years ago, I'm not even sure it would have been possible. It's amazing to me how fast technology evolves, and that's probably why I recommend just stay curious in your career, right? Because if you stop learning, your career's dead. I'll just tell you, like basically, it's a learn or die environment in what we're doing. Even if something as simple as designing a road.
Good.
And I say that as someone who could not design a road to save my life.
Yeah. I have a few more questions, but I will probably get other people's questions first. So Faith.
Hi. I'm just curious about in making the digital twin of a infrastructure asset, how many days or months it takes for you to like complete it totally?
It depends on the complexity of the asset. The Brent Spence Bridge is, it's going to be years in the making before it's constructed and built with all the sensors built into it. A data center is a matter of months, right? So a lot of it is just dependent upon the complexity and the size of the infrastructure you're talking about.
Okay. Thank you.
I think we have a few more hands up. Shubhashish.
Hi, can you hear me?
Yes.
Okay, so I have a question. Like you mentioned in your discussion about Floodtraps, a tool which works with real-time data and like gives flood prediction, which helps decision making. So I was wondering, does it only work with the water level data, or it also considers like infrastructure failures, for example, levee or dikes that is placed in that region?
It does. If they happen to have, for example, a flood diversion structure that's not functioning right now, they plug that into the model and it incorporates that. It's actually been real-time modeling via AI. So if they have a flood, like I said, that flood diversion structure or a control gate at a lot that's no longer working, they will incorporate that into the model and into the recommendations. You know, they can't just say open the floodgate because it's not working, right? So it's going to have to present a different option to try and address or alleviate the flooding. And one option might be evacuate, right?
Yeah, okay. But what about the probability of failing? For instance, like a levee breach or something, like the water level is so high that it's overtopping the levee. So does it calculate that probability and gives um, early warnings or something?
It does it in yes, and it does it in 15-minute increments.
Okay.
Because the severity of the storms in that part of our country, they can be very intense. So hourly would not be sufficient.
Okay, got it. And I understand that this tool is not available for public, right?
It is not. It's a
Yeah.
tool that was developed by the engineers in my company.
Yeah, but can you suggest me some tools that maybe simpler tools that is available for public to use, similar tools?
Sure, I can ask and send that information on.
Okay, yeah, that'll be very helpful. Thank you.
You bet.
Thank you, Shivashish. Sudipta?
Hello. Yeah. So thank you for your presentation and to respond to your question that I am also really very surprised and to see the depth of digital twin. And my questions also are related to that. So I have a couple of questions. So my first question is that so you are saying that you are using for it for different structures, and on your example, you said that you are also measuring or estimating the scour for bridge that you are working on. So how digital twin incorporate those things means you applied you or your team give any data set, then the system takes into it, or how you deal with that?
I'm sorry, you broke up a little bit there. Can you repeat the last part of that question?
Yes, means how the digital twin system incorporate the scour or any other thing means you need to give any data set or how you do that?
Well, it becomes dependent upon your ability to capture that data. So when I talk about the data capture layer of the digital twin system, whether that be through sensors that can detect and monitor it. So think about vibration sensors or heat sensors or piezometers when we're talking about geologic movement, just as an example, or continual data capture through like drone detection for pavement condition, right? So the first requirement is that it has to be something that can be detectable through either continual data capture or some type of sensor that can be embedded in the infrastructure itself. If it's not something that if it's not a real-time condition that can be captured in one of those two different ways, then it's almost virtually impossible to include in a digital twin.
Yeah. Okay. Yeah. So, and just, and to, you also give any historical data set also, or only the real-time monitoring? Because real-time monitoring is the main thing, but do you sometimes compare it to the other cases?
Yeah, the flood traps is a really good example. So it's pulling real-time monitoring information, but the model is continuously informed by and updated by historical performance of that infrastructure. You could run a model that said, hey, if I had a channel that was this wide and this deep and I got this much rain in this amount of time, it could roughly predict what was going to happen. But a better model is one that says, hey, when we got this exact amount of rain before, and it happened 4 days after another rainstorm that gave us this amount of rain, and so the ground was already saturated this amount, I experienced this amount of flooding, right? That's going to be much more accurate than just a raw computer simulation based on very simple factors, right? So a good digital twin, like in that flood tracks model, is going to incorporate what really happened in the past and combine that with what's happening in the moment to predict what's going to happen in the future.
Oh, yeah. That's great. And my last thing for today, I just want to know that how differences from your cases, from your experiences, you in applying digital twin for different structures or different cases. Is it so much difference, or there are similar cases also? Means I want to mean that if you want to apply it for flood or want to apply it for breeze, then the case is totally different, or how much differences do you need to face?
There are some similarities, there's some differences, but there's quite a few similarities. To your first question, I have to be able to capture real-time information, right? So there's various types of sensors that you can use to capture that, or data capture devices to collect that information. I always have to have some type of secure network to transmit that information back to whatever hub I'm using to model or make decisions from. That's similar in every instance, right? I wouldn't want any random hacker to be able to get into my water treatment plant and change how my system is performing and pose a threat to the community, right? So those things are similar every time. What's different is I can detect this, but what does it mean, what this type of infrastructure, right? What does it mean when I get this amount of movement in a road versus a bridge versus a runway versus a water pipe, right? That's the part that differs from each scenario.
Oh, yeah. Thanks for your answers and insights.
Thank you, Sudipta. Any other question from anyone? Brian, I have a couple of questions. I was just very curious about the flat tracks model. So the flat tracks model, like, what's the extent of the model? Like, is it like for a local area, like a community, or like a kind of a statewide, or?
The first implementation of it was for all of Mecklenburg County in North Carolina. Mm-hmm. So that's if you're familiar with the U.S., that is basically the city of Charlotte, North Carolina.
Yeah. Okay.
So it's several different watersheds all in one.
Mm-hmm. Okay. That sounds great. Yeah, this looks like a very interesting tool. So my second question is like, because I think we discussed a little bit, I think there's a confusion in the engineering community as well. So when we are talking about digital twin, I think you mentioned in the very early of your lecture, people think more like a 3D model that was built in one, right? But it's basically like what we mean digital twin is basically it would like behave the similar way that the real structure behaves, right? But
Yep.
but like again, it's hard because a structure behaves in so many different ways, and we have only limited capacities of sensors or to like capture in some of their behavior, right? So is there a minimum level that you think that we can call it digital twin? Like, I mean, we won't be able to like probably capture everything, how infrastructure behaves, but how do you like, what's your thought on that?
That's an interesting question. Like, what's the minimum threshold that you consider the digital twin? I mean, this is the opinion more than anything, but an affected, I mean, if all you were caring about was settlement on a bridge, right? That's a digital twin, right? It's fulfilling your need of that twin. Is like if I'm only really caring about settlement, if I'm only really caring about flood level, right, and I can detect it in real time and I can make decisions based off of that, then that's a good enough digital twin for me, right? I don't need to be able to capture 10 real-time pieces of information about this infrastructure. If the problem I'm trying to solve only requires that I have one, then that's good enough.
Yeah, no, that's a fantastic. That
Again,
makes a
that's
whole
just
lot
my
of sense.
opinion.
Yeah, no, that makes a lot of sense. So, like we're targeting the intent of what we're like using it for. So that makes a whole lot of sense. Oh, great. And Brand, as you're involved in a lot of these works as part of the ULPERT, so what's your thought? Like, how mature is this industry? Is there a lot of research and development needed on this area, or digital twin is definitely talk of the town, but like when we start looking into like some stuff, like we don't see a lot of maturity in those areas. So what's the level of like industry at this point, do you see?
I mean, if I had to say, one in conceptual, 3 in the infancy, 10 is a fully mature entire industry at that point, I'd probably say we're at a 4 or a 5. I do think there needs to be a lot of R&D, both on the I'll call it the technical side. The question about can I just go buy a package digital twin solution? No, I think, and I don't think you're ever going to be able to. That may be a bit skeptical on my part, but what I do think is that there can be standards developed for how systems communicate. I mean, think about buying a computer, right? Whether I buy a Mac or a Dell computer or some other type of computer, an IBM, they all have a USB port in them, right? So there's been a standard developed that if I want to plug a peripheral into my computer, that USB is an acceptable standard to do that, right? So where I think a lot of R&D needs to happen is on the interoperability standards of the different components of the digital twin. I don't think we're ever going to get to a situation where I'm just going to buy a digital twin. So I think there's that piece that needs to happen. I also think, particularly when it comes to AI and machine learning and how those can factor into design efforts, I think there's efforts with the end users, the clients, the state departments of transportation when we're talking about roads and bridges, the FAA when we're talking about airports and airspace, where there needs to be R&D efforts that allow them to be comfortable with and provide acceptable use cases where they'll allow those technologies to be used in design efforts.
Yep. No, I agree with that. So I think there's a lot of like movement or like work I'm seeing on the AI side of it, at least like on the standard side, like even in the universities, like we're trying to develop the standards or guidelines for AI. But I think in the digital twin is still lagging a little bit behind, like just to my opinion. Obviously, there's a lot of talk of the town, but I mean, I don't know like how much work is going. So I was like really excited to see the flat tracks that at this we have an example now that works. Um, no, great. And I think like I really liked one of the thing that you mentioned at the end. Like if you stop learning, your career is almost dead, and that I can also like attest that because um, in my last 10 years of in the industry, I saw that like unless I was curious, I'm interested to learn new stuff, right? The way or the pace that I am learning and the pace that industry is moving, it's like not linear relationship, right? So I had to always catch up with like learning and stuff. But with a relation to that thought process, a lot of the students or like maybe a lot of the young engineers, they want to learn digital twin, but do you have any suggestion where they can start from or like any sort of ideas like, okay, I want to learn digital twin at this point because I see that's the future, but where do I start with simply?
Uh, I would get familiar with Revit. I would get familiar with Python scripting. I would get familiar with databases and how data is stored and organized and efficiently retrieved. I probably would start with those three, and that'll get you a good start, a good foundation.
Yeah, thank you. Yep. I think that's all of my question, but does anyone has any other question or any other comments, thoughts for us or Bran?
Well, thank you, everyone. I appreciate the time. I appreciate the great questions, and I appreciate the opportunity to speak with you today.
Well, thank you very much, Bran. I think we really appreciate your time and a great presentation. I think this is talk of the town, as I say, like a lot of people are curious about it. So I'm glad that you covered most of the materials and at least gave us an overview of what it looks like and what's the future look like. Thank you, Bran.
You bet.
Have a great weekend.
Thank you all. Have a great weekend.
You too. Bye-bye.
Thank you. Bye.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.